everyone. My name is Jennifer Daw, and I'm a senior researcher at the National Renewable Energy Laboratory. The focus of my work is on the integration of energy, water, food, and land systems. I have a background in water engineering, and you might ask yourself, what is a water engineer doing at an energy lab? Which is an excellent question. Before coming to NREL, I worked for 10 years in the water and wastewater sector, and I was focused on civil engineering projects like drinking water pipelines and water treatment systems. What frustrated me about that work is that I felt we were missing the big picture by just repairing and replacing what was existing and not thinking through more innovative solutions. And so that grew my interest in the concept of sustainability. Sustainability is development that meets the needs of current generations without creating adverse impacts on future generations. Sustainability is often characterized by environmental, social, and financial considerations. A natural extension of this is the concept of the energy, water, food, or land nexus. This is an emerging area that reflects the need for sufficient and secure energy, water, food, and land supplies to meet both our current and our future needs. Demands on these resources are becoming increasingly interdependent due to trends such as population growth, climate change impacts, urbanization, as well as changes to development patterns. Development choices we make can affect all three of these systems: energy, water, food, and land. And traditionally, these systems work in silos. The Nexus emphasizes cross-sectoral solutions where we look for synergies and co-benefits across these systems by viewing problems more holistically and considering their impacts on social, environmental, and economic factors. To build resilience, planning should consider the complex interrelationships between energy, water, food, and land systems to understand their trade-offs and to devise different approaches that may address those challenges. While competing demands for resources poses challenges, it also creates opportunities for innovation through more integrated solutions. NREL's area of expertise around integrated systems ranges from modeling and analysis to water and power system integration, technology validation and deployment, policy and decision support. To date, more of our emphasis has been on the integration of energy and water systems, but we are seeing more and more emphasis recently on food and land-based research and how these all intersect together. Some examples of the work that we do include modeling and analysis, which is going beyond optimizing systems to look at multi-sector and multi-scale impacts, as well as energy, food, and land system constraints. Integration of systems through concepts such as energy and water microgrids, where the water system can serve as a dispatchable load for the energy system, and they can be co-optimized. Technology validation, which looks at the integration of renewable energy into technologies such as water treatment desalination, testing in our energy systems integration facility through hardware in the loop to assess grid services, but also impacts on water quality for different treatment technologies when they're run 100% on renewable energy. This work also includes things like field demonstration and validation of technologies. And finally, policy support and analysis and market expertise that we can bring to help inform decisions that are being made by our partners. So what does this look like? An integrated energy, water, food, land system for a remote or island community. One example could be PV and land use. We're doing a lot of research now looking at co-locating agriculture, such as pollinator habitat or grazing land for goats, with PV arrays, instead of a traditional land treatment that you might find under a PV array like gravel. Additional research in this space is also looking at stormwater quality impacts from PV development and how treatment can influence it. Sites have improved soil health, they retain water, and they nurture native species, as well as produce food and provide even lower cost energy to local communities when they're using more native habitats under the PV arrays. A great example of this is an island community that I visited in the Caribbean called St. Eustatius. In St. Eustatius, they installed a PV array where they're collecting rainwater to use for community agriculture as well as for cleaning the PV panels. This leverages some of the intense tropical rain while also providing food supply and reducing some of the burdens on food supply chains during an emergency, and building energy resilience by decreasing reliance on diesel fuel imports. There's also additional study on emerging technologies such as floating solar panels that can be put on underused water bodies and improve the water quality of those water bodies, also pairing them with hydropower storage reservoirs and aquaculture. When trying to develop more integrated systems, there's a few things to consider. First, in your planning decisions, take a step back and consider the intersection of your project with energy, water, and food land systems. Identify the relevant stakeholders to engage in your project discussions. Work with stakeholders to identify positive and negative impacts on each system and the broader impacts on sustainability associated with your projects. Some impacts may require more detailed modeling and analysis to assess. Work collectively to identify win-win solutions that leverage trade-offs and opportunities through more integrated system planning. Some great examples on how to approach integrated planning across the energy water food nexus can be found in the resource library that we're sharing here. Thank you for your time, and we look forward to working with you.